And hey everyone! Today, I'm diving into some seriously fascinating science that's changing how we think about cancer's deadliest trick, metastasis. You might already know that most cancer deaths aren't caused by the original tumor, but by cancer cells breaking away, traveling, and setting up shop in other parts of the body. But have you ever wondered how these cells survive such a grueling journey? Well, a team at Rockefeller University just uncovered a piece of the puzzle, and it all starts with a tiny molecule called glutathione. Glutathione's usually famous for being an antioxidant, fighting off damage inside our cells. But what if I told you that, for cancer, it's got a secret double life? Using some cutting-edge technology, think protein tagging and spatial metabolomics, researchers tracked glutathione inside breast cancer cells that had spread to the lungs. They discovered that these metastatic cells were loaded with glutathione, way more than the cells in the original tumor. But here's where it gets wild. The key isn't just having glutathione. It's about getting it into the mitochondria, the cell's powerhouse. There's a special protein on the mitochondrial membrane called SLC25A39. Its job? Shuttling glutathione into the mitochondria. And if you knock out this transporter, those metastatic cells can't grow in the lungs. It's like pulling the plug on their power supply. Now you might think glutathione is just mopping up free radicals, but nope. In this case, it's actually switching on a transcription factor called ATF4. That's a fancy way of saying it helps cancer cells survive in harsh, low-oxygen environments, exactly what they face when trying to colonize a new tissue. So, rather than just fighting off damage, mitochondrial glutathione is giving cancer cells a survival edge when they need it most. This isn't just a lab curiosity. When the researchers looked at samples from real patients, they saw higher levels of SLC25A39 in breast cancer that had metastasized to the lungs. Even more striking, patients with higher SLC25A39 levels had worse overall survival rates. That means this transporter is more than a molecular oddity. It's a potential target for new treatments. Imagine a future therapy that blocks SLC25A39. By stopping glutathione at the mitochondrial door, we might be able to slow or even prevent cancer spread, all with fewer side effects than more generic treatments. As Kavance Biersoy, the lead researcher, puts it, if we want to understand and fight diseases like cancer, we need to zoom in, right down to the level of organelles and their metabolites. So next time you hear powerhouse of the cell, remember, mitochondria aren't just making energy, they're making decisions that can mean life or death, for cells and for us. Thanks for watching. Let's keep questioning, keep learning, and keep pushing science forward.